Hi, welcome to this online presentation for the ISU Symposium on Undergraduate Research and Creative Expression. My name is Carter Krieger and I'm a junior in software engineering. My mentor was Yanbin Jia from the computer science department. My project was a high-speed polyhedron vision tracking project. The goal of this project was to track a polyhedron-shaped object being tossed through the air, which would involve reconstructing the edges of the shape, finding the corner points, creating a data structure of these edges and vertices, and then displaying a motion path of the object and rendering a view of the object by reconstruction of the shape. Some of the challenges involved with this were the high-speed toss across the scene would require the tracking techniques to pick up on these very quick changes, as well as the low color distinction from the background, as you can see with this pretty light shaded of white against the background of a lighter gray, as well as these edges being faint sometimes with the lighting changing, and the requirement of real-time processing to be able to keep up with the quick movement across the scene. The method for this first involved taking the input frame in the video. We then would perform a background subtraction from the original frame to get a view of just the shape separated from the background. We would then use this to find a region of interest. So we're finding this smaller area in the background where we can draw a bounding box around this and only perform the operations on a smaller region to save computation. We then find the external contour around the shape, so this approximates the outer boundary. Then we perform a convex hole operation on this contour in order to find a little bit larger region here that's convex and has straighter edges along the outside. We can then use this convex hole to mask the region of interest so that we're only searching inside of that convex hole area where we know all of the edges on the shape is contained. We then perform a canny edge detection, which will find these edges, including both the internal and the external. We then use the Hoff line algorithm to find these line segments using the Hoff line probability version. So this will find these segments of two endpoints, and then we're able to use these segments and points to bin the segments together. We can do this by inserting segments into one bin that have a similar angle and position, and then averaging the position of that to get these red lines here. Using those new binned segments, we're able to extend them to longer lines, and in this next step, you see we find these intersection points here, and then we're able to check the corner history compared to previous frames, and if those intersection points / corners are close to the former, we're able to plot those here as these purple points. So here you can see an overall tracking video being slowed down a bit, but being tossed across the frame. The green dots are representing roughly the path it followed, and you can see all the other features updating as it goes. The results of this project were the good motion tracking aspect, the object segmentation, where we're able to separate out this polyhedron object from the background. We performed edge detection successfully, segmented while we binned the segments. We created a intersection structure to find those points again, as well as mapping out the general path with those green dots in the former video. Some further developments that I did not complete yet include adaptive object segmentation for a changing background, could be a future direction, using the stereo depth data from the two cameras, creating a doubly connected edge list structure as we find the edges and intersections, as well as then live 3D rendering from the doubly connected edge list, we can then recreate the 3D object. Some future work that this could go to is applying the vision techniques to my honors project in the fall, which will be an autonomous mobile robot to catch tossed objects. The motion tracking and adding in estimation will be really important for this, as well as using the high-speed stereo cameras for additional depth information at the fast rate needed to catch the ball, and the ability to potentially track more than just one type of known object. And that's all. Thank you for attending my online presentation for the symposium.